All right, this is now past climate. Direct evidence of Earth's climate only goes back to about 140 years. And by direct evidence, they mean like where people wrote down the temperature. When people started using modern equipment to measure the physical parameters of the atmospheric and, oh, yeah, like I just said, humans have recorded details about local past climates in written records, stories, art, and oral histories. In fact, some of that um, and there was a mini ice age. No, it wasn't the Younger Dryas. There was a different one, but we know that it was like super cold and like just short of being ice age-ish because of paintings from Europe that show like, springtime holidays or festivals and stuff, like where it's snowing and they're ice skating and whatnot. Um, and then phenology records our records of natural seasonal variations. Vocab word. Evidence of climates past. So, how do we know beyond that 140 years? There are many different things we can look at, and some of these are not it's an all-inclusive list, include pollen, tree rings, insect feeding patterns, paleosols, meaning ancient soils, marine fossils of shelled organisms, and other things. There's geochemistry we can look at, ocean and lake floor sediments, and the gases trapped in ice cores, and oxygen isotopes from minerals that have been precipitated uh, in the ice cores. And not that they were precipitated in the ice core, but the oxygen isotopes in the ice cores for sure. Oxygen isotopes in critter shells, things like that, help us reconstruct the past. And so these little diagrams show the concept of the oxygen isotope. So there's two oxygen isotopes. There's oxygen 16 and oxygen 18. Oxygen 18 is it weighs more than 16. So preferentially, oxygen 16 wants to evaporate because it's the lighter one. But during an ice age, as it's precipitating out, um, also, if some 18 does evaporate, when it rains, it's going to rain first, and the other ones, the oxygen 16, the lighter isotope, is going to stay in the clouds and in the atmosphere longer until it gets cold enough that it rains or snows on an ice sheet or a glacier, but then it's trapped there. And so over years and years and years of the oxygen 16 becoming trapped, then the ocean waters elsewhere become more concentrated in oxygen 18. Until eventually in the ice cores, you can actually see where it's like there's almost all of the oxygen 16 has kind of been trapped here. You start seeing an increase in even 18 being precipitated up at the poles. As well as you can see, like I mentioned, like the critters, like when they're taking oxygen, like, making their shells, you can see this trend as well. And so that's how oxygen isotope and this concept can all be correlated back to climate. And here's just an image of an ice core. And so they can go through, they can measure those isotopes, they can measure the CO2, there's little itty bitty air, little gas bubbles all throughout ice. And so they can kind of like poke into one of those and analyze the gas content. And then here is a correlation chart showing carbon dioxide, methane, and temperature for the past 400 years. And you can see that there's definitely a correlation between the three. Like that's just, you can't deny that. Um, and then geoengineering. So, we're like, well, how do we fix this? We don't like this. What do we do? One, try to not use as much carbon dioxide. But also, can we improve things? So we're trying to actually like do like carbon capture and storage, CCS, where we're actually trying to, and it's not like we go around with a vacuum sucking CO2 out of the air, but we can try to like catch it at like manufacturing plants and things like this. And then what we do is try to store it somewhere. One of the places we store it is in the ground in like old oil reserves, like old, um, we haven't talked about oil yet, but just in the ground where we think it won't be able to escape. Um, okay, another idea. reducing the amount of sunlight striking Earth's surface. I think you might have heard that. I think it was Dubai tried cloud seeding, and that sounds like such a good concept. Like we'll just put more clouds in the sky. But they had a very big flood afterwards, so obviously we need to practice this a little bit more. But very good concept. I've always kind of wondered too, like, why don't we just put like a bunch of, I don't know, mirrors or something like over the ice sheets and like help that reflection back into the solar system. But so we're trying to like do things like this to try to change the amount of greenhouse gases we have in the atmosphere and the amount of solar radiation hitting the surface too. And that is it.